Now let's look at another application of binary variables, and this is called set covering problem. Now we have this example, several cities for an airline company that they serve. Now they want to locate a hub, one or more hubs in the selected cities from this list, such that all the cities in the list can be covered by flights. Okay. So if you locate a hub in a particular city, which other cities will that hub be able to serve? And we have a restriction here that any city that is within 1000 miles of the hub, it can serve. If it is more than 1000 miles away, then the hub cannot serve that city. Now we have that list here given to us. Okay. If you locate a hub in Atlanta, then these are the cities that hub can serve. If you locate one in Boston, then these are the cities that particular hub can serve. Now the question is, we have to serve all the cities, so what is the smallest number of hubs that is possible, and where should those smallest number of hubs be located? So that's the problem. Okay, let's see how we can set this up as a binary variable problem. So here is the Excel file, and here are the cities, and we have coded already into zeros and ones, okay, for cities that will be covered by a given hub. Okay. So if you look at the Atlanta hub, okay, Atlanta can serve Atlanta itself, and then Chicago, Houston, New Orleans, New York, and Pittsburgh. So those are the cities that will get a 1 for the row Atlanta. For row Atlanta, you get Atlanta gets 1, Chicago, Houston, New Orleans, and Pittsburgh. And similarly Boston, Chicago, and so on. So this is a table that we can prepare based on the data given. So the setting up of the problem is fairly straightforward. All we have to do is to set this up as our changing cells. Okay, used as hub or not, the decision is 1 equal to hub, 0 is not a hub. Okay. So let's give a name to this. Now we'll do a sum product of whether you'll have a hub or not in a given city, and that. Okay. So here each city, okay, will cover, okay, if you have a 1 in any one of these cities, okay, and that row, the city indicated by that row, will be covered. Yeah. So that should be greater than or equal to 1. Okay, not exactly equal to 1, because if it is exactly equal to 1, you are introducing unnecessary constraint. So if it is more than one hub can cover a city, that's all right. The only thing is we don't want any given city to be left behind the series. And the total number of hubs is simply the sum of that row. So that gives us the total hubs. So let's name that. And this is what we need to minimize. That's our objective function. Covered by and required. Okay. So when you multiply this with this, then you know that a given city will get covered by the number of hubs that will cover that particular city. Let's now run solver. We want the total number of hubs to be minimized, so that needs to change to minimize. And that is our objective, changing cells, and that covered by should be greater than or equal to the required, so we can just simply type in the value of 1 there for required, and that should be binary. Okay. Non-negative and simplex LP. We solve, so you get 3 hubs, Atlanta, Boston, and SL is Salt Lake City. Okay. Now in a problem like this, this is called set covering problem, it is likely that you may get more than one optimum solution, multiple optimum solutions that we talked about early in the semester. So it's possible that when you run, you get a different combination of zeros and ones with 3 as the total number of hubs.